Let's get it. So I kind of lied to you. I was like, yeah, just one more. Nah, there's too much stuff in this section. I'm going to have to do 2 more videos. So let's just jump right into it. So here's our theorem 6.1, position from velocity. Position, displacement, not the absolute value like distance. So given the velocity v of t of an object moving along a line and its initial position, got to know initial position, s of 0. The position function of the object for future times t greater than or equal to 0 is, so our position function is, well, position at times t is equal to its initial position plus the integral from 0 to however far you're going, however time 0 to t of our velocity function. And that gives you a lot of stuff, but I mean, come on, man. Let's say you're 10 miles from home, and now you're going to go travel north at 50 miles an hour for 2 hours. So 2 times 50 is 100, plus you were already 10 miles away, so it's 10 plus however far you frickin' traveled. A lot of notation for this, but it's not that bad. Okay, let's check it out. So let's see a nice simple problem. So let's look at some, here's a velocity function. It's just sine of t. And we're going to go from an interval from 0 to 2 pi. All right. But we're going to say our initial position is just 1. No units, none of that nonsense. Let's just go and let's see this one. It's not a tough problem. So we're going to say that our position function, let's start with the position function, is going to be equal to, well, where we started. So I guess we started 1 unit in the positive direction. 1 plus. And now we need to take our integral of our velocity function. And it's just from 0 to 2 pi. Our interval here, our a and our b, of sine of t dt. That's not so bad. So it's just saying you got to add frickin' 1. You just got to add whatever your initial position is. You got to add 1 to it. So, all right, here it is. 1 plus. And then the antiderivative of sine of t is negative cosine of t, evaluated from 0 to 2 pi. Now, that's going to end up being 0 at the end. I hope you know that. You know what I mean? 1 plus. So now we have negative cosine of 2 pi minus negative positive cosine of 0. Well, cosine of 2 pi or cosine of 0 are the same exact frickin' things. Okay, so this is 1 plus the quantity of negative 1 plus 1. That ends up being 0. So we got 1 plus 0, which is equal to 1 frickin' unit. But that's the game. That's what we're going to mess around with. We give you an initial position. You just got to add it. You just add it to whatever the integral is going to be. All right, next piece. Oh, wait a second. Velocity from acceleration. This is the same game. It's the same freaking game as what we were just dealing with position and velocity. Now we're dealing with velocity and acceleration. Now I'm going to jump aside and just do this real fast to make sure we're all on the same page. This is our position function. I like to think of, oops, come on, man. I like to think of derivatives going down and antiderivatives going up. That doesn't really mean anything. But our velocity function is just equal to the derivative of our position function. Oops. This is our velocity. Fun. And if we were to do it again and we get an acceleration function, well, that's just the derivative of velocity, which is equal to the second derivative of our position function, and that's just our acceleration. But we're going to go this way, right? Derivatives are Calc 1. Still need to know them in Calc 2. But now we're going to do antiderivatives and go the opposite direction. So it's still going to work the same way. It's the same thing as what we just did, just different sorts of ideas. Look, given an acceleration function of an object along a line and its initial velocity of v naught, well, the velocity of an object for future times, or t greater than or equal to 0, because less than 0 doesn't make any sense. Well, it's just going to be our initial velocity plus the integral from 0 to t of our acceleration function. So we could do the same gosh darn thing. We're just going to mess around with it where I don't know. Maybe we do the same freaking problem as we did before. It's the same thing. So let's just say that we have an acceleration function that's equal to sine of t on an interval from 0 to 2 pi. And our initial velocity is just equal to 1. What do you think the frickin' answer is going to be? It's going to be 1. It's the same thing. We just have to know that the context of how position function, velocity, and acceleration are all tied together. So we're always going to get the same idea. So we would just set it up, and we're like, well, I want a velocity function. Well, that's equal to its initial velocity. And then we'll go from 0 to 2 pi of sine of t dt. And I don't want to run through and do all that nonsense. You know what I mean? I think that's just too much. It's 1. It's 1 unit per time unit. There it is. All right. Now that we've done this, let's start to play around with an idea of, I'm just going to give you a couple things, and we're going to mess around with them. I like these problems. These are good, like, I don't know if they're test level problems. I usually do this more in Calc 1, but I'm going to give you an acceleration function. It's equal to negative 32, and I'm just going to call it feet per second. I usually don't like to mess around with the British imperial system, but F it, let's go. And then we're going to have an initial velocity of 70 feet per second. Oops, that's feet per second squared. Come on, man, be better. Be better. Acceleration is the unit of time squared. And then we'll have a position function, which is just going to be 10 feet. Now our game is, we want to find a position function. We want to find s of t. Just a function for the position. So here we go. We're going to start with the acceleration. And we want to get a velocity function. So we already have our acceleration function. That's right here. Let's go. And you're like, but what's the units of time? Doesn't matter. Doesn't matter. So this is equal to our initial velocity plus the integral. Actually, no, it's not. Hold on, sir. I don't want to remake this video. Let's do it this way. Our velocity function is equal to the integral of negative 32. And I'm going to use dt. dt. And you're like, but why would you put in the plus 70? We don't need it yet. Well, let's just see what happens. Are there bounds? There's no bounds. There's no time. So what we're going to do, we just run through. We're like, all right, so our velocity function is equal to negative 32. And then we got to just add a variable plus c. But that's not plus c. It's the initial velocity. So our velocity function is negative 32t plus 10. Oh, ship. I was saying ship, not with a T. Plus 70, right? Because that's the initial velocity, v naught, right here. Now we want to keep going to go get that position function. So we got to take another integral. So we're going to say our position function is just the integral of our velocity function with respect to time. All right. So let's go. So we end up with, what is that? Negative 16t squared plus 70t. Now I'm going to write plus d. Because there's no bounds. It doesn't tell us the time. But I'm sure you got this. D is just our initial position function. Therefore, s of t is negative 16t squared plus 70t plus 10. And there we have it. There's a full-on position function. All we have to know is our initial position, initial velocity, and give us an acceleration function, and we can create the position function. All right, got it done in under 10 minutes. We'll have probably just one more pretty mellow one, and then we will move on to the next section.